Welcome, everybody. Tonight we're going to be working on Module 6. The topic for tonight is object-oriented programming. And let's look at quickly at the agenda here on the second slide. So we're going to talk about all these topics here tonight. So we're going to talk about what objects and classes actually are in programming. We'll learn about constructors or constructor functions, if you will. Then we'll learn that we can also pass objects around as arguments for use in our programs, which is very, very powerful, by the way. We'll learn the concept of overloading, and then we'll look at some custom collection types, and then kind of tie it all together. Right. We have a little splash screen here for objects and classes. But as I was saying, before I started recording this presentation, it's this language that we're learning, C#, is an object-oriented programming language, and many modern languages are, right? And it really kind of falls to the most fundamental aspect of what we're doing in programming, and it's really this concept of abstraction, right? And so this is kind of a weird word to throw at you right on the first slide, but it's the collective body of what something is and does and what it contains, and then thinking of it as one thing instead of a bunch of little things. So for example, if I was to look at you as an individual, well, you have certain properties about you, like you have a name and an age and a height and a weight and whatever, like think of whatever personal details you want. But you also have capabilities, like certain things that you're able to do. Like, for example, apparently my great skill is taking the garbage out or walking the dog, for example. So like if somebody wants that task completed, often I'm the one doing it. Not that others aren't capable, but apparently that's one of my methods, right? So, and I'm using this terminology with a lot of intent, and you guys might not pick up on this immediately, but the whole concept is that if I can refer to all of those properties that I have and all the capabilities that I have and still think of me as a singular person, that all those properties and capabilities travel with me, and then I can just call upon them to execute. Now you're starting to get the picture of what object-oriented programming really is all about. So let's start talking about the slides here, and then you'll kind of see what I'm talking about as we go, and I think that might help the picture come in clearer as we're talking about it. So first, let's talk about this concept of an object, right? And it says here, software component that exists in memory. So in other words, when your code is running, if you've created an object, it is real in the fact that it's executing in RAM or your storage area of your program. So two things that objects are able to do. They have what we call data fields. So in other words, they have, and people will call these by different names, right? But I was kind of just referring to them generically as properties, right? Like, so for example, I have data related to my name, data related to my age, my height, my weight, etc. Right? So an object has the ability to store data, and not just one piece of data, but multiple pieces of data. And then also it can do things, right? So an object can perform operations. And notice we say when we're referring to objects, we call them methods, right? We don't call them functions, but that's really what they are. So methods are really functions that are built into an object. And if you want to make the correlation, it's like my capability of taking out the garbage or walking the dog is one of my methods, right? And remember, I use that terminology when I was describing it. And it says C# also gives us a structure called a property that can get and set data. So there's kind of the tie-in with that word. And so there's a capability to kind of like generically store information, but there's also properties or values that are kind of embedded into the object just by its nature. Like, for example, my age is not something I would have to store in an object about me. All I need to know is my birth date, and the age is calculated. It becomes a property, as opposed to a data field where I would set a value and retrieve it, or maybe change it and do some math, and kind of like a regular variable, really. And the question pops up: what examples of objects have we used so far? And you know what? I'm not sure that you're able to really answer that off the top of your head, but when we are working with, for example, the console write line, even is a really good basic example. So the console apparently is some sort of an object inside of C#, because then I can add, with a dot coming after it, write line with parentheses, which is a method inside the console object that allows us to put stuff on the screen. So that's a method that's part of the console object, right? And okay, so that's kind of a primitive example, but that shows you that you've already been working with them and maybe just haven't been aware, right? That's really what it is. The question at the top of the slide: what defines the fields, the data, and the methods, the operations an object can have? All right, so it says a class describes a type of object, and therefore a class is basically a custom data type. Now, this is kind of deep, right? And here's an example of what this means. When we work with strings, we think of a string as a data type. So I can say string first name, and I can, put some double quotes in there, throw my name in there, right? And then we think of that as a variable. The reality is what is a string? Break it down and think about what a string is. A string is a collection of characters, or an array of characters, or a list of characters, right? So if I'm like putting a word together, it really, individual characters build the word. Collectively, they become a string. So even though we think of a string as a regular data type, we're building that data type. It really is a class or an object that we're building. So if I can utilize that, and we don't think about it, we just utilize it. We utilize the string as what it is. Then I can build my own data types as well that have a class definition, and then use them, right? And you might not think of a data object that you want to create, but that is entirely possible, and that's really what you're doing. All right, so let's look at this. It says classes define objects, and it says until now we've been using a class file as a container for statements and local functions, but there's so much more, right? Okay, so this is kind of a little bit cheesy, but it is totally true, right? When we are using, for example, a couple of variables here, so they have like a double for miles driven, a double for gallons used, and then we come up with this other thing that is kind of like, what are we doing here? We're getting a function, right? So somewhere in the program, there's a function, and we're calling it, we're sending in the stuff, and it's returning a value and placing it here in miles per gallon. All right, so that is one of the capabilities of an object, is that you have functions built into them that do exactly that kind of stuff. They do calculations, they do sorting, or whatever, whatever the program is doing. And you can call upon the functions in the object to do specific tasks without utilizing any other part of the object. So for example, even in the little Codio thing we were just kind of messing with before we started here, we were using get length. Well, where's that coming from? Right? Well, that's a function that was built in that allowed us to extract that piece of information from that object that we were dealing with. So all along, you've been kind of utilizing these unknowingly, right. So now they're doing this comparison, and this is really kind of a lot of definitions here, right? So first we're looking at value type, and what we're saying here is data type versus object. So for example, a value type is simple. So an integer, for example, it's a primitive data type. In fact, we have multiple different types of integer data types, each with different capacities. But creating one is really simple. You just say int, give it a name, throw a value in there, and you have it. And what is it? Well, it's a number stored in a memory location. Very simple. Very, very simple. But when you're working with an object, like the random number generator, that's an object. And it does more than the simple stuff that we've done with it. But if I want to use that in my program, I have to call upon it. I want you to notice a couple of conventions here. There's a capital letter at the beginning of it, which implies that it's an object, right? And and so what is random? It's okay, think of it as a custom data type, but really it's an object that has data fields and values and properties inside of it and methods and capabilities. And then if we want to create it for use in our program, we use this keyword new. And then notice the parentheses. That's kind of weird, right? Why the parentheses? The parentheses indicate we're running a method or a function. So somewhere in this object called random, there's a function or method called random whose job it is to create a new version of that object. Okay, so now we're hitting upon another concept. So I have the archetype or the blueprint of the object contained here. And then when I run the function, it creates a copy of it that is not the blueprint. So this is kind of like the Menard's example coming back to haunt us a little bit, right? So think about this, right? Think of my constant example of like, hey, I want to build a house. I don't run down to Menard's and buy a bunch of 2x4s, a hammer, and nail, and get busy, right? What do I need to build a house? I need a blueprint. I need to know what I'm building, how I'm going to build it, how much material I need, which nails, what kind of nails, yada, yada, yada. But having the blueprint, then all I have to do is take everything that's in that blueprint, create it as is, and I have a new version of the blueprint. So when I use new, that's calling on what we call the constructor function to build a new object based upon the blueprint. All right, so I know, kind of deep, but go with me on this, right? It'll make sense as we keep pressing forward. Now, following on this value type thing, it says value type variables can't do anything. They just store value. So if I do an int whole number, put 99 in it, well, okay, there's 99 in that variable, right? And it says when declared, the compiler sets aside enough memory for the variable's value. So why do we have 4 or 5 different integer data types? Because they each have different capacities, right? And how we use the memory in a computer determines how efficiently our program runs and how efficiently the user's computer runs as well, right? So we want to be efficient and only use the memory that we need. All right. Now, let's do a little comparison to objects here. With objects, there is, okay, so this is kind of interesting the way they put it. The object itself in memory, okay, this is kind of weird. So like when we create that object out of the blueprint, it does exist in memory of the computer, all of its data, all of its capabilities. And then there's also what we call a reference variable that holds its memory address. So a separate storage thing that points to that object so we can utilize its capabilities. This is kind of so when we're using that new keyword to construct the new object, we're now also have a reference point to memory. It's like, well, here's this object and it does all this stuff and holds all this data. And where's it located? Oh, it's over there. That's what we're talking about. And the analogy here that says like the string attached to a kite, use the reference variable to interact with the object. So in other words, I can't touch the kite once it's in the sky, or if you will, once it's in memory, but I can use other things to interact with it. In this case, the string becomes a reference variable to interact with the object. So really what happens is the blueprint is like the kite, and our ability to interact with it is that object that we've created, right? So it becomes like the reference to the object. All right, so here comes the constructor function stuff again. So if we're creating an object, we first declare the variable name that's going to be the new version of it. So the object the blueprint that we're building from is car. So this has some sort of data and capability. We're calling it my car, and we're making a new car named my car, right? And the my car, the variable name, is really the reference variable to point to the new object. So one of the things that we are going to get into here, and I'm going to demonstrate this little program thing here and talk about it a little bit, is we're also going to break out of the paradigm of working simply inside the main method of a program, and now we're going to reveal the larger structure of the program, which includes the namespace and the class structure for the main program, which we've been kind of ignoring all along because we hadn't talked about objects and classes yet, right? So it makes very little sense. So here, I'm going to pull up Visual Studio. I am going to create a new project. I'm going to try to do some of the stuff that we're showing here on this slide. All right, so I'm going to hit the next button here. I'm going to make sure I'm going to the correct folder. This is pretty typical for us, right? And I always have to struggle to remember where I put my stuff, but we're going to select that folder. And then I'm going to call this module 6. This is 6, right? Examples. That setting is fine. It's when we get to the next slide that we're finally going to change our option here where it says do not use top level statements. So we're going to basically, by clicking on this, we are going to reveal the top level statements. It works, I think, opposite of how they describe it personally. All right, so I'm going to go ahead and create this, and then we're going to very quickly kind of review, what this all means, right? So like, this is really what a C# program looks like, by the way. What we've been doing is we've just been working inside that set of curly brackets the whole time. We aren't seeing the fact that we're working in the main method or that we're working inside of a class file already inside of a namespace. All right, so this is kind of like these layers that are happening here. Now, functionally, what I often tell my students is, the namespace piece for Visual Studio really kind of came into prominence, and I know about like 8 years ago or something like that, where they enforced the namespace. Normally, you would write a C# program and that piece of it wouldn't be there. What is the namespace? The namespace is the container that holds all the stuff. So when you look over here in your Solution Explorer, and we haven't really been in the practice of like really looking at this stuff too much, honestly, the namespace is the large container that holds everything and it's named. Right, so that is just a naming convention. Okay, so why do they do that? Well, what if we have a program that has multiple namespaces, and if I have multiple namespaces, then I can have multiple programs called programs. They're called program.cs, right? So when I have this internal class in a C-style program, a class really is the root program of our program, right? And so we just call it program. Now, it could be called anything, but the default when we create a C# program is to call it program, and then the file name that goes with it is program.cs, right? But usually we're writing code that obscures this information. Actually, it obscures this information too. So all of that is obscured. All right. Once you have a program, you then have what we call the main method. And the main method is the part of the program that automatically executes when you hit that play button up here. It executes. So if there's statements inside the main method, they run. If I took that console write line and removed it from the main method and hit the run button, nothing would happen. I wouldn't see anything on the screen, right? So if it's not in the main method, the program's not running. Right. Okay. So why do we have to point this out at this point? Well, because the program that we're writing in and of itself becomes a class, and all the methods inside of it are relevant and can be called from outside the program by using the dot notation that we will be learning as we kind of start dealing with objects. Okay. So that's kind of the general lay of the land. So let's go back to doing this now. And let's talk about this little thing that they have here. So it says the C# API provides many, many classes, right? And it says often our programs need more customization. So in other words, what they're saying is the API is an application programming interface, meaning, hey, we already have this stuff that's all built in, like the random number generator and console write line, and whatever other things that we're used to calling already that we don't think of that exist as separate objects, but they do. But they're built into the core of the language, and if that language piece is missing, then we call in the library that contains it, and then we have access to it, right? However, when you're writing programs that are dealing with very specific topics or issues, and you're trying to solve a problem, often you're in the situation where you need to create a simple class in order to have all the capabilities that you need to make your coding easier. So in essence, you could think of it as creating your own API. Right? This is the interesting aspect of it. So here's the thing that we're going to try to do here as we move forward. It says we will create a rectangle class. Rectangles will have a name, a length, and a width. The ability to set a new name, length, and width. The ability to retrieve that information or get that information. And then the ability to get the rectangle's area. All right, so I want you to think about all this stuff and the terminology that we're using here. So rectangle will become our class or a blueprint. That blueprint will include data fields, or basically variables, if you want to think of it that way, that are the name of the object, the length, and the width. And then we will have, when you see the word ability, that means like a function or a method, the ability to set. And these are like keywords, right? So set means to put a value in something, and then get means to retrieve that value. So in programming, we often call these getters and setters, by the way, right? So this is the terminology. And thankfully, C# has a very beautiful way to deal with that. And then also another ability, in other words, this would be a calculating method that will take the length and the width and return the area. Right. All right. So let's kind of keep flowing through this. The rectangle class fields store values, name, length, and width, and then methods or functions will provide the behaviors, right? So updating the name, length, or width, so that's setting, or getting or retrieving the information of the same, and then doing the calculation. So look at the thing that is at the very bottom of the slide, though, because this is important terminology too. When we combine all of these things together, all the data fields and all the methods, we call this the class's members. So the methods and the data fields become members of that class. Right. Right. All right. So we're going to start by doing exactly what this says. So I'm going to use this program that I've created here. And what I'm going to do in terms of creating the class structure on this, and this is kind of interesting because normally, we're coding inside the program class, inside the main method. This is the executing part, right? So if I'm going to add another class to this file, I have to do it at the same level that the current class is at, right? So you see, like the program class is one indent in, right? And the next class that we're going to create for rectangle is also going to be one layer in. So I'm going outside the program class, but inside the namespace. And now I'm going to just say public class, and I'm going to call it rectangle. And I want you to notice that the convention for building classes is to use a capital letter at the beginning. So that's a convention, and I'm not sure that it's a rule in C#, but nor, and it's not in Java either, but that defines it. The class keyword just tells us basically it is a program class, and then public means that it can be accessed from anywhere inside this program and from outside this program. If I wanted programs outside of this program to not be able to access it, I would change that keyword to private. So only this program could access it. If I make it public, then other programs outside of it can access it. So that's kind of powerful. Right, so that's step number one, right? So public means it can be used anywhere in our program. All class members go inside the curly braces. So the methods, data fields, all that stuff goes inside that set of curly brackets. And properties will likely be used most often, but we'll explore several types of class members. Okay, yeah, we certainly will. All right, so the next thing that we're going to do, and we're going to copy this in basically, but you can type it in as well, is we're going to declare our data fields. And this is really pretty interesting. So the first, you know what, I'm just going to copy this code in and then we can talk about it. How about that? So the first thing that we're going to do is we're going to drop in a string variable called name. And I want you to notice here, the name of the string is set to private, meaning I can't, from outside of this class structure, change the name. I have to do it with the tools inside this class. Public, however, could be set from outside. So these two, notice a property for length and a property for width. And then notice this really weird little convention here that we can get and set these. This is kind of weird also. So in other words, the capability to set the value of the length or retrieve the value of the length can be done externally, right? You should be very, very thankful because, you know, if we were learning this in Java, and I know some of you might know Java already, in Java, we have to manually create the getters and setters. We have to write methods that do it and label them as such. C# makes it so simple. We just set it to public or private, set the data type, name it, and just say, hey, we need getters and setters for this, and it will happen automatically, right? Has anybody here ever coded in Java? Okay, right, like, okay, so if you've done Java and you've done objects and classes, that's one of the things you learn, right? Is like, oh, I gotta code all these getters and setters. And then, you know, a lot of my students finally figure out that depending on which IDE they're using, you can automatically generate those. Like you just do a right click and create them often. But this is kind of one of the first steps here, right? To be able to get and set these items, right? So we will kind of play with this a little bit as we get going. This is probably the easy way to do it. We'll tinker with this as we go. I'm just telling you that as we go, we will probably adjust these. But we're following the examples on the slides. So it says the variable name is a private field, right, for name, and the variables length and width are public. So we already said that, right? So now we're going to kind of apply it to an issue. So here's the issue. We have a house that we're building. Thankfully, most houses tend to be rectangular. Most rooms tend to be rectangular, right? And this, you know, makes calculations generally pretty easy. So it says, imagine, you know, looking at a floor plan like this, and you are looking at what kind of floors you're going to put in each one of these rooms. It's kind of a classic, you know, home rehab kind of problem, right? So like you're going to go to the store and you're going to buy flooring by the square foot, and you need to know how many square feet of that flooring that you need so that you can buy the right amount. You don't want to buy too much or too little, right? So calculating it is helpful. So each room is basically a rectangle, right? Give or take a little bit, right? Because like you see, this master bedroom obviously has a little jut out here, but they're saying it's 13 by 12, so I take them at their word, right? Every room has its own name. Every room has a length and a width, all right? See how that matches up very nicely with our rectangle, you know, class structure, right? It says the rectangle object for the kitchen has its own length and width, for example, and then it's in a different place in memory than the bedroom rectangle object, right? but they're both built from the same blueprint. So ultimately, they both point back to the original blueprint, but they are unique entities. And so, a really good example I can give here, right, is like if you are building a house from a blueprint, and you probably have seen subdivisions like this where, like every house is basically the same house. And what makes each house different? I don't know, the siding, maybe the roof, maybe this one's got a dormer and that one doesn't, or that one's got a 2-car garage, that one's got a 1-car garage, whatever it happens to be. But the houses are essentially the same. They're not really different. They came from the same blueprint, and then when they're created, they are unique objects, right? And that's kind of a helpful thing to kind of keep in mind. So the rectangle data type, and it says one way to think of an object is as a collection of related values. Okay, true, right? So if I look at the kitchen object, well, it's got a name and it's got a length and a width, right? But when I create it from scratch, when I do this, what I'm really creating is an empty object that does not have the length and the width predefined. In fact, it's empty when I first create it. So then we will enter into the getters and setters to set the values. Okay, so that will happen internally. But if you just do the creation of the object, whatever this constructor function says to do, we will do. But often when you're creating it, it is created without any values stored into it. Now, what's kind of interesting about this, right? So, and I'm just going to go back to the code here. So whatever I do with this rectangle class, this is not a program that I can run. So I can't like go up here, hit the play button, and then this will do something. That's not how it works. This can do it, but only because it's got a main method. So that's the only executing part of our code. So whatever we do inside this set of curly brackets will allow this to become and do the stuff that it needs to be, right? So on its own, you can't run it, right? So it's a blueprint, once again, and I like that analogy a lot. It will be used by the class that has a main method or uses the top level statements featured discussed in module 1. And this is called the driver class, and then there's only one per project. So in other words, I create this program file here. I can only have one program in this program file that has the main method, and then ultimately this method drives everything in our program. If it's happening, this is causing it. If it's not in here, not going to happen, right? Even if the code is here, this won't do anything unless the main method will call upon it. All right, so what they'd like us to do here is create a program called flooring calculator and create the rectangle class as we've got it so far, right? And this is classes can be added below the program class or in a separate file. All right, so this is kind of an interesting thing. So you could take this and create a separate CS file that you put in the same folder. Now, that is, like if you were really doing this stuff for real, that's probably what you would do. But I like putting the other class definitions in the main program body, at least for now, until we see how they operate. But knowing the fact that I could pick up this code, create a new file, and put it in it, and still have it operate the same way, that's pretty powerful. Think of the advantage of that. Then I can pick up that file and I can move it to any program I want and have all the same capabilities available that travel with that object. Right, so that's kind of the thing. All right, create the rectangle classes. We got it so far. It can be added below the program class or in a separate file. Okay. In our program file, create a rectangle object. All right, so let's do this one at a time, right? But we're only doing this as we've got it so far. So in other words, we're not building the methods yet. We're just building the data pieces, right, that we're shown above. So we kind of have that going, but then we need to also, in our main program body here, we're going to remove the console write line, and then we're going to call upon that class to instantiate a new rectangle object. And they give an example here for kitchen, right? So we're going to say rectangle kitchen, new rectangle. All right, so let's do that. I'm going to say rectangle, and notice how it finds it, right? It finds it because it's sitting right there. And notice how it highlighted it. And we're going to call this kitchen. So we just give it a variable name. And we're going to do a new rectangle, empty parentheses, and then a semicolon. Right? So when I run this, it will create a new rectangle object in memory. And that's all it's going to do. Let me show you. All right, so I'm going to run it. It'll build. It's done already. It built the object in memory. Program's over. Now the object's gone. And that is the other aspect of it. So because this is a blueprint, when this object is created, it is only there while the program is running. The moment the program stops, it's erased from memory. Okay. So we did create it. We just couldn't see any of it, right? And because we didn't set any values, we can't retrieve any values to make sure that we created it. So that's kind of coming next. Now, the other aspect of this that I think is kind of interesting is the fact that this constructor function right now is empty, but we can also set it up so that it receives values upon construction. If you set up your constructor function to do that, or overload your constructor function to do that. We'll learn that as we kind of progress through the evening. So hang tight, and we will get there. All right. So that was the first piece of it. All right. Next part, right? It says every room will have its own name, length, and width. So we're going to need multiple rectangle objects, and you can make as many as you want, right? So for example, if I want to make a bedroom and a dining room, I can do that. So I can just come up here and I can just follow the same pattern and say rectangle, dining room, and a new rectangle, and another one called, I don't know, bedroom. And, maybe we have multiple bedrooms. So this is bedroom 1, and that's also a rectangle. So now I'm creating 3 copies of this blueprint. All of them are empty, but I'm creating 3 copies. So 3 of them would exist in memory once I do that. Okay. So this is kind of some interesting terminology here because we throw these terms around a lot. And this word instance that you see in that first sentence there, it says an object is an instance of a class, right? And in the process of creating an object, we call it instantiation, mouthful, right? For sure. Practicing that one really 10 times fast. And then when we said kitchen, new kitchen, rectangle, and a new bedroom rectangle, we are instantiating 2 rectangle objects. That's kind of how the terminology works. But whenever you hear a computer geek talk about instantiating something, you know what they're talking about. That means you're taking the blueprint of an object and creating an object in memory, right? And it's kind of like a in the know kind of thing. So if you're talking to a programmer and they start saying instantiate or instance or instantiation or whatever, and you have a glazed over look, they know that you don't know anything about object-oriented programming, right? So that's one of those words you want to learn. And as we start to create the objects, I'm going to try to intentionally use those words, right? And this is just part of programming, folks. Just getting the lingo down so that when you talk to other programmers, they know what the heck you're talking about. So let's take a look at this example here. If we have 1 rectangle per room, how do we actually get the values assigned to each room, right? So this is kind of a thing. So we think about these as the data properties or whatever of this object. And we also can call them instance fields or data fields. So this instance has these data fields. In C#, they tend to use the terminology of instance fields. My comfort level really comes more from Java, where we say data fields. That's kind of the thing, right? So every rectangle object gets its own length and width properties and a name field. These are called instance fields. No, really? How? Okay. All right. So what they're going to ask us to do here is to apply values to the object. So for example, to access an object's fields or method, use the variable name plus a dot plus the member name. So like the property we're trying to affect. And in the flooring calculator, can you set the length and width, right? And how about the name, right? So they're giving us an example for the name. So let's give that a try, right? So let's go back over here. And now the thought you might have is like, okay, well, I should set that down here. Nope. No. This is the blueprint. We don't set anything inside here. This is a piece of paper. This is the house, right? That's the way to think of it, right? This is the blueprint for the house. This is the creation of it. Well, the creation of the room, right? So if I create all of these objects here, if I come down here and say kitchen dot name, right? And where is that pulling from? Here, right? That's where that is. And notice how they're doing it. They just say kitchen dot name equals kitchen. Okay. And so then it behaves kind of like a regular variable, right? So I'm going to use a capital K on that, right? Because I think it'll look better. But now we're just taking that object and we're applying the name to it. Now it's highlighting red. Oh, it's inaccessible due to its protection level. That's kind of interesting. Okay, so why is it doing that? That's because this is set to private. So for a moment, I'm going to set it to public and notice that go away. So that shows you like when something is set to private, I can't change it from out here. Yeah. And so we'll learn about that. And basically what we do is we write a method that sets the name, so that, but if it's public, we can set it externally, right? So we can also do the same with the other ones, right? So like if I want to do like dining room or bedroom, right? I can just basically do this, right? So I can say dining room name, bedroom name, and notice how I'm being a little more particular here. Bedroom one is kids' bedroom, or favorite kids' bedroom, or oldest kids' bedroom, whatever, whatever you want to put it in there. All right, but that's like forcing values on those properties. All right. And it says in the flooring calculator, can you set the length and width? All right, well, let's take a look at that, right? So I can do this, right? So we can, because these are public fields, right? We can do this exact thing. We can put in values. Notice they're going in as doubles because that's what we defined them as. And then we can right line it. So it says properties are commonly declared as public. All right, so the length and the width. And notice that those typically have an uppercase letter to start, and they're available outside of the class. So I can refer to them from the main method. A property stores data in a private field, which cannot be accessed directly. The set method is called with an equal sign, and the get method is called when the property is referenced by name. All right. So let's go ahead and try exactly what they're doing here. And I'm just going to copy these, and I'm going to add them to my program. Right. So now this property is accessing this in the blueprint. This one is accessing this. When I use an equal sign, it's letting me do a get. When I am console right lining it, it is doing, or excuse me, this is doing a set. The equal sign get is setting the value. This is retrieving the value. So it's doing a get. So if you want to like add, stuff, comments here, you can say, this is a set. You can put quotes around it if you want. So is this. This is a get.
Well,
So it's getting the value. And you know what, just to kind of prove the point, right? I can also right line the width. And if I want, I can also, well, I'm not going to do the dining room, but I could also, for example, take the kitchen. And since I've set the name, I'm going to print out the name. So let's do that. And in fact, maybe the name should come first.
question for you. In the public class rectangle under public double length, can it be reversed to set and get, or does it have to be get and set?
Yeah, that's a really good question. I guess I've never tried it. Here's how I would find out.
So we can understand like, okay, we
Okay.
know sets
It looks like
first,
it
get.
works.
Okay.
Anthony, that's a great question. I've never tried that before. In all the years I've played with this, I've never once tried that before. But the convention when we talk about get and set is we call it getters and setters in that order. I don't know why. That's just that's the convention we've always used. Um, because probably more often you're retrieving information than applying the information. Because think about that, right? If I'm doing calculations, I'm going to set the kitchen information once. And then when I do calculations, I might get it a whole bunch of times. So I can see why they would use get first. It's probably more used as a fair thing. All right, let's go ahead and run this. We are going to be creating extra objects we don't need. And even though we're setting their name, we know what? Um, we could just kind of be silly here just to show, right? So we could do a console right line. And since we set the name for dining room, and since we set the name for bedroom one, we can also extract those values. So I'll just show you that we're putting the values in and then we're able to pull them out of the objects. So here comes the run. This isn't going to be very exciting, but it's proof of concept, right? And so if we pull this over to the side here, when we're right lining, it shows you that the kitchen object is created. We're able to extract its name. Then we're able to extract its length and width. And then we're able to extract the names of dining room and kids' bedroom after setting them. These, however, right, this was originally set to private. I'm going to put a little note here just so we remember that. Okay, because we probably will end up switching it back. We'll see. Right. All right. So that's kind of the example. I'm doing a Control S to save, by the way. Let's go back to the slideshow now. Let's take a look here at this field access slide. We got another slide, and then we'll take a break, by the way. It says fields are private by default. So if I'm just creating them from scratch, private will pop up automatically. And that means, as we've already kind of described, it's hidden from outside this class, but it is recommended to explicitly say they are private. So in other words, if I skip this modifier, right, public or private, and I delete that, well, notice what happened to all of these name fields up here. All of a sudden, they're not working. They're by default private, right? So I'm going to Control Z that for right now. Okay, so then the question becomes, but how can we access them if they're hidden? Well, all right. What we do is basically we create functions. We can retrieve the information from them, but we can't set the information without using a method. So it says here, an object-oriented program, classes hide their data, control access by creating public methods or properties. And then that's kind of the thing we're going to do next. But we are going to take a break, right? And before we go to slide number 28. So I'm going to pause the video. All right. So we're back from the break and we're moving on to our next slide finally here. And you'll notice the little title that sits above it. And we're getting into this thing called a mutator, right? So we'll learn what that concept is. So if we have the name field set to private, how do we end up changing it? Well, we have to write a method or basically an internal function in the class that is allowed to do the changing. Right, so this is how we do it. I want you to notice the naming convention on this, right? And if you think back to your Codio exercise that we were working on with the get length thing, where that might come from, notice that we call it by convention the name of the property with the prefix of set. So we say set name, capital S, capital N, right? And this is just kind of a naming convention that we use. And you know, capital letters on both of the logical words. And then instead of directly being able to set the value like we did here, right, where we just brute forced it, then instead we call that method to do the work for us. Okay, so here's what I'm going to do in our program is I'm going to go ahead and switch this back to private. And then I am going to borrow this code precisely, and you guys should do the same if you're coding along, right? And down here in the class, I'm going to paste in that method. I'm going to switch this back to private. And then all of these will underline red because now they're no longer valid, by the way. And I am going to use some CSS style comments here to comment that out so it's not, you know, running. Now, right now, this is still underlining red because why would that underline red here? Because we haven't set the name. So instead of doing kitchen.name, now we're going to use the method to do it. But before I do that, let's go ahead and take a look at the next slide here, because that's pretty much what they're going to demonstrate here, and the naming convention and why, like, for example, we use this word void in the method. Okay, so let's go to the next slide here. Right, so it says because the scope is within a class, so it's inside the blueprint file, this method is not a local function. So it's not part of our main program. It's only part of the object. So it's only accessible to the object. So we call this an instance method. So it's inside the instance that we're creating, and it operates on instance fields only. Notice that also has what they call an access specifier. So public, meaning I can access it from outside the class if I want. Void refers to the return type. This is saying that this method or function does not return anything, right? So that you should sort of recall from the functions, right? And then set name is the name, and there is a naming convention for it. And then, of course, the parameter list. And in order to set the name, yeah, think about it, we need to send it as a string to the method. Notice the continuation of the use of the question mark, which allows it to be null, right? So it's nullable if necessary. But this is kind of how we do it. Okay, so let's try this a little bit, right? And I know they're going to make us try it later as well, but let's give it a shot. And what we're going to do now is we're going to refer, this is weird, right? Because we've created a kitchen object, and that method is inside the kitchen object itself. So if I say kitchen, right, and then I go dot set name, see how it pulls up on the list? That's available to us. And then what it's expecting inside here is the text that we used before, which is kitchen, right? So there you go. So we're calling upon the method inside the object itself to set the name. Okay. And if we're doing it with the kitchen, well, we can do it with the dining room. So I can say dining room dot set name and then put dining room. And then notice below as I add these how the underlines go away because now it's valid, right? So you'll notice provided I spell it correctly, right? Yep, dining room. And then we're also going to do the bedroom. So we'll do bedroom 1 dot set name, and then we'll call it kids bedroom. Right, there we go. Now these are still underlining, right? It says it's inaccessible due to its protection level, but you know what? It's trying to retract or pull that information in. So what it's telling me is because it's at the private, it can't read it. Okay, so I can't really run this yet, but this is the way I would set the name. So in other words, if I want to retrieve the name, guess what? I have to make a method to do that too, right? So that's where it gets kind of interesting, right? So let's follow the stream of the slides here. And it says, why was the parameter called n? All right, so this is kind of an interesting thing. Why don't we just call it room or something like that? Well, we can call it whatever we want, is really the truth of it. But that variable is only accessible inside that particular method, right? So call it something that makes sense. N is kind of short for saying name. So that's why I think it's a good choice, right? Could we have called it name like the field name? Okay, well, the answer to that is probably not a good idea, right? Here's the why. Just like, we're building this object, name is a valid thing here, but then we're saying it's a valid name inside here as well. And then notice what happens. Does it let us do it? Sure, lets us do it. Notice it underlines green though, and it says name may be null here. Okay, that's not much of a warning. It's generally considered just a bad practice to do that. It's not that it's illegal. And when we've talked about this, relative to Python, where in Python, that's kind of the convention in Python, is to name everything the same and whatever. Here, I'm always a lot more cautious in a traditional language, by the way. So should we have called it name? I think the general answer is no, right? We should not have called it name. Another issue that we kind of start running into is this concept of scope again. So like where things are valid given their names inside the coding brackets, if you will. So inside the curly brackets. So it says scope is where a variable or method can be referred to by name. Instance fields are visible to all instant methods. So in other words, all of these are visible to any of the methods we have inside of here, right? Makes sense. Sure, right? So public instance fields can be accessed by the code outside of the class. We've kind of demonstrated this already. By setting this to private, all of a sudden I can't even read this information back, right? These names are underlying red because this is set to private. These are set to public, length and width, so those aren't a problem. Inside this class structure, all of these are accessible by any of the methods. So this kind of explains why we don't want to name that the same as this, because this is an incoming value, right? It's being sent in, and then we're applying it to the internal field. If it comes in with the same name, it's not that it doesn't know what to do, but it's confusing for both you, the programmer, and I'm going to call it not good practice, even if they're used to doing it a different way in Python, by the way. Right. There's also this concept of shadowing, and it says you can't have two local variables with the same name and the same scope, and this includes parameters. So this is the reason why you really don't want to do it. You can have a local variable or parameter with the same name as a field. The local variable shadows the field, and the field is hidden by the local variable. So what they're saying is you kind of can do it. So here's the example, right? And this is what we just played with, right? So if I put name there, how does it know which is which, right? And so we know because we're sending in that this one is the one we're sending in, but is it? Right? Like which one are we setting? You know what I mean? I can't change this one because this is an incoming value, but this is one that's internal that I can set. But how do I know which is which? They have the same name, right? Right. So this is actually what ends up happening. It's taking the external one and sending it back to the external one, meaning the other one isn't getting changed. So if you're using the same name, we do have a convention to work around it. And then we use this keyword called this, right? If you've done this, this in Java, you'll recognize this keyword. If you've done this in JavaScript, you'll recognize this keyword. We also use, I think, the same keyword in Python, if I remember correctly. But this is kind of weird because this one refers to the one coming in. And if we say this dot name, what is this? Well, this object that we're working with. So this name is this one. So it refers to itself. So it's self-referencing is really what it is. And so if you insist on naming them the same, then you have to use the this keyword to make that work. So, and it says the this keyword references the current instance of the class. So whatever object, if it's the kitchen or the dining room or the bedroom, that's the one it's referring to, the one that's inside, right? And the example is we have one instance so far that we can access with our kitchen reference variable. Now we can clean up our set name method to try to use it. All right, so let's try to do that. Let's change this to name and this to name, but here we're going to say this dot name. Notice the underlines go away, and now we're okay. Or you could have used the first approach. That's fine too, right? It doesn't matter. But if it's hard for you to understand like what is what, then naming it the whole way and using this keyword in front of it is a perfectly reasonable way to go. But this refers to the current object, whichever one is in memory. All right, so that allows us to set the name. We still are in the situation though where we can't really see the result of it, right? So, all right, and I'm looking here at my other example code. Okay. All right, we're going to look at other examples too. I'm trying to look at my examples from last year, and they're a little convoluted, frankly. So we'll just kind of keep building up normally. All right. So to use the set name method, we've already kind of put this in play. We've also learned that we can't retrieve the information until we create a get name method, but that's coming, right? A couple of points we still have to make about this though. All right, there's some conventions that we also use. So, and it says to avoid shadowing, the convention for private fields in a C# program, this is not true for every language, by the way, is to use a underscore as the first character of the variable name, and therefore it's private, and you don't have to use this keyword. So let's do that. Let's change it, right? And that was one of the examples I was looking at, in my example code. I'm like, oh yeah, okay, I see how we got there, right? The slideshow kind of dictates it. So if I switch this to underscore name, it also becomes like we use all caps for a constant, right? It shows us just by looking at it that it's a private field, right? Just by naming convention. So I think that's pretty darn helpful ultimately. Okay, let's keep pressing forward with the examples here. All right, so this is kind of what we have so far, right? We have a little more in our program, but whatever. So we have a new kitchen rectangle. We've set the length and the width, and we've set the name, right? The kitchen is a reference variable to the object in memory. Its data type is rectangle, right? Custom data type. It holds the memory address of a rectangle object, which has all the kitchen information in it. Okay, so that's the thought. All right. Here's kind of a weird little thing, right? So we can go through and we can set the name, create a new object, set the length and width, set the name, and then we can go in there and set the length, and we can set it to something that doesn't make sense. Okay, so think about this. If we're doing dimensions of rooms, under no circumstance could we have like a negative length. We could have a 0 length. It's a really small room, right? But we can't have a negative sized room. Doesn't logically, it does not make sense. So what we could do is we could put in what we call validation to the set method for the length property to make sure that it sets correctly. All right, so this is kind of weird. But this is kind of one of the values of building objects this way, because we can hide the logic of this from the outside world. So how we did it before is we would have private double length, right? Well, that's not how we did it. We actually did public double length is how we did it, right? If we did it privately, we could put that in. But if I did this, would I be able to access it from the outside? No, right? So this gets a little weird. So let me just do this and I'll show you kind of where we're going with this. Is I'm actually gonna, in front of this line, I am gonna create it as a private. So I'm gonna say private double, and then notice no question mark here, but we will go with the underscore length. See, Visual Studio knows where I'm going with it. And then the public one, notice the set of curly brackets here. We're going to have different directives here. So the get is going to return the length, and the set, if the value is greater than 0, then the length is the value. If it's not, then we're not going to allow it to be set. So a room can't be 0 size. Then it's not a room, right? If it's got 0 length or width, well, I guess it's not there. Right? So here's what we're going to do then is we're going to take this set of curly brackets here and we're going to add it in place of this get and set. And I don't like how that laid out, but hey, let's clean it up. And have it look like that. Okay, so that's kind of like the example. And so this is kind of strange, right? Because now we have this public version of length that we can send values to and pull values from. So this would pull the value from. This one would set it. But what is it setting? A private data field inside the object. So this is a way to allow external access to get and set, but still keep it protected inside the object. That's what we're doing, right? And really this if statement should really be written like that, I think, right? So you can see it. All right, so now we're able to get and set the length. All right, let's take a look at things to note here. So it says, when the rectangle object was first created or instantiated, what values did name, length, and width have? And we know the answer. The answer is nothing, right? Okay, not true. The numbers had 0 and the string was null. That's really what was in there. Unlike local variables, fields are initialized with default values, right? Numeric type set to 0, strings and objects are set to null. It is an error to omit the parentheses when creating an object. So when I do this, this will throw an error, right? So these are kind of helpful little tips so far. All right, so now they have a try it out for us. And we're moving into a different section called accessors, by the way, right? Okay, create a program that has a second class named pet. Okay, so we're gonna do this inside the same program. So like I have a class rectangle, I'm now gonna create a class called pet. I do want to make this public so I can access it from outside. Public class, and we'll call it pet. Curlies. Okay. And I know at some point here, they're going to ask us to put in some properties. The pet should have 2 properties, a string called name and an int called age. All right, so let's go ahead and add that. And I just conveniently have this pre-created, of course, in my other file. So I have a public string name. And notice because it's public, it's a capital N, right? And then a public int called age, capital A. Both have getters and setters. Once again, this class could be its own separate file called pet.cs, right? And if it's helpful later on, I can demonstrate that. But for right now, this is simple enough to do it this way. In the main method, create two objects that are instances of pet. Right now, I have a couple of issues with my code up here, right, where this stuff isn't really quite working right now. So what I'm going to do is I'm going to comment all of that out for right now, and then later on we can turn it back on. But for the moment, they want us to create a couple of pet objects, right? So let's do that. And create two objects that are instances of pet, set the name and age values for each object and print out the values. Okay, so we're just going to practice that. So here comes my example of that. And you know what? Since we're not doing any of the house stuff right now, right? Let me just take this comment mark. I'm just going to move it here and then move all that code down. And I'm sorry, I blew it away by doing that. All right. And then we'll do the pet stuff here. So I'm going to say pet. I'm going to call it, I don't know, dog equals new pet. Okay. So for me, my dog has a name. And let's just put in the real name. What the heck? My dog's name is Abby. And it dog also has an age. So I'm going to say dog.age. And she's not 10. I think she's probably about 8 or 9. I'm just going to say 9. And then I want to output this. So I'm going to console right line, the dog name, and then console right line, the dog age. Okay, so it did it for me, right? And so practice this. You guys should try this too, right? And then we'll also do another pet. And this time it'll be cat. And I happen to have multiple cats, so we'll call it cat 1, right? And we'll create a new pet. And then we'll say cat 1 name. And let's see, which cat shall I pick? Let's go with Mojo. I think is our youngest cat in the house. Yes, we have more than one, but hey, that's how it goes very often. And then age, well, probably a year old, I think the cat is right now. And then we are going to console right now the name and the age. All right. You see how Visual Studio just knew what I was going to type and just did it for me. So once again, the whole process, right? Just to kind of reiterate, we created a class called pet with 2 fields, right? Both public. We were able to create new pets, name 1 dog and 1 cat 1. And then we applied a name and an age, and we're going to output the name and the age. Same with the cat. Let's try it, run it, make sure it works. All right. Abby's 9, Mojo's 1. We're good. So this is working. So we're creating 2 objects. We're putting information into them, and we're able to put it on screen. So we're setting and getting the information, right? This statement sets, this statement gets. All right. So that's just a practice, right? So, and practice makes perfect, so you do it over and over and over again to kind of get the thing. So we were able to accomplish that. So that's good. All right. Things to note. What if we want to print a rectangle's name in our driver class? And we, this is the little kind of red underlines we were getting before. And it says, think about the scope and the private access rules. The same visibility restrictions apply if we want to read and print a field's value. So we'll need to write a method that returns the value in order to put it back up on screen. So now we're going to add this to our program. So here's the code for that, by the way. So in the rectangle class, we're going to leave the name as private, but now we're going to write a method, right, that will allow us to send the name back to the program. I'm just going to copy that code, folks, Right, so here's the copy. And we are going to have one problem with it. You guys will see it as soon as I paste it in. So now I have a set name, and now I'm adding a get name, and that's going inside the rectangle class, right? Now notice, because this is set to private, really I need to change the name to the underscore name. So it's going to return underscore name to our program. All right, so we have a get name and a set name, right? Notice that the return value, this is kind of interesting. The return value has a question mark on it too, because if it happens to be null, because this is nullable with the question mark up here, the return value has to also be nullable, right? So that's kind of the why. All right, so now we can go back to the main program body, and all this stuff that we commented out, right? Now we can comment again. So what I'm going to do though is, just for the sake of not confusing the examples, I'm going to comment out the pet stuff now and then uncomment this stuff. And now all of our stuff really should work, right? Okay, no, wait a second. Here, okay, so I want to kind of point out, set name is going to work. I can't use this approach, right? Because that is not accessible. So that version does not work. Okay. And then here, when we're doing the return statement, instead of pulling the property directly, which I can't do, even if I put the underscore in front of it, if that's what you're thinking, it's still red, right? I have to use the method, which is get name. So I'm going to say get name and parentheses, right? Because it is a method, so I need the parentheses after it. So wherever I have name in a get, we're going to replace it with get name, and then that reaches into the object, runs that method inside the object, which has access to the name internally. So in other words, this function has access to this when we don't. So I have to call the function to return the value. And the reason that we do this is so that somebody can't just like willy-nilly change it. So often, when an object gets set, sometimes you don't even have this. It's hard coded into the object. But we'll talk about that later. Right? But now notice we are able to do this. And I'm keeping all the kind of old examples in here too, right? And just tweaking my code a little closer together. But now we can do the same for all of these. So let's run this and make sure that it works, right? So here's the run, right? So it is pulling back the name of kitchen, the length and the width, which we've done before. And then now it's getting the name for dining room and kids' bedroom, where before that we weren't able to access it. So we learned two other pieces of terminology here. If you guys kind of picked up on this, we have what we call mutators. The mutator would be, for example, the set name allows us to change the name or mutate its value externally, where otherwise we would not be able to. And then this then becomes an accessor, which allows us to pull the information back in the aftermath of creating it when we don't have access to it directly because it's set to private. Right. Okay. So I'm going to go ahead and terminate that program execution there. And we are going back to the slide. So kind of recap that by looking at this, using the get name method, we create the object, we set the name with set name. And then when we're putting it back up on screen, we're using get name to retrieve the name from the object, right? That's just kind of the recap. The concept of accessor and mutator methods. Okay, so having private fields and public methods to retrieve and update them is extremely common. All right, so this is, kind of an interesting thing, but this is really, really common, and not just in this language, in most languages, in languages such as Java, we can't do like the shortcut approach where we just say get and set. You have to write out the methods. That's kind of interesting. And like I mentioned before, that's why you use like an IDE like Eclipse or something where you're coding Java and you create your data fields and then you do a right click and it says, automatically create getters and setters. Boom, it's done. Right. Because it's such a common action. You'll see with C# that it's a lot more flexible than Java in that capacity. The simple get set approach is really useful. And then they also made this properties approach. And it says here, this is why C# made properties, is because it's that common, right? So they just kind of shortcutted it. Methods that return a field's current value are accessors or getters. So we use both of those words. So getters is the same as an accessor, right? So when we say get name, it's a getter or an accessor. Ones that change a field's value, that's called a mutator or a setter, right? So those words are interchangeable. And once again, it's kind of one of those computer geek programmer in the know terminology things. So if you're talking to somebody and they're talking like mutators and accessors, they're talking about getters and setters. Or if you're talking about getters and setters, they're talking about mutators and accessors, right? Not necessarily in that order, by the way. Right. Properties, conversely, it says here, are specialized members in C# classes that allow for ease of storing and updating data, all while securing the data from direct access. So for example, if I create a product, right, we have a product class, let's say, and we are able to set its price, I can just directly pull that price in. No getters or setters are needed. So this is what, when we talk about properties, this is what we're referring to. This is a property by definition, right? I'll be real frank, I don't often worry about the definitions in my head when I'm doing the work, but I get how it works, right? I'd say that this is the easiest approach, but it also does become dangerous because you can change something that easily, right? There's another aspect to doing these objects and classes, right? And it's this concept of what we call data hiding. And often what we'll say is that we think of it as kind of like a black box, right? As a common analogy too. And it says it's a foundational concept in object-oriented programming that objects hide their data, right? We can only access the data through methods that are public. And we might not be able to access it otherwise. And maybe that's just to keep that object safe, right? This puts you in control of like what you're allowing people to see or not see, or what other programs can see and not see. And, for example, you can also use this to enforce logical conventions or reasons for your program. Like, for example, no negative rectangle dimensions. In fact, everything's got to be greater than 0. Otherwise, it's not even really a room or a rectangle, right? As a rectangle cannot have a dimension that's 0. Because then it's not a rectangle, it's a line, right? It also helps to conceal what's going on inside. So for example, this is a really good example because strings, when we use strings as a data object, really it's a class or an object. And what we're really hiding is the fact that a string is a list of characters. Kind of, there's your tie-in. The one weird thing though is like if you guys ever switch over and code in Java, when we create strings, it's always the capital S because it shows you that it's an object. It in C# it also is, but they use the lowercase s. I don't know why, they just do, right? But normally when something is an object, it starts with the capital letter. All right, and then one little goof that I made, really, because all of these things that I created here, I did them all with lowercase letters. The convention really is they should all be uppercase, right? Because that way, when I look at it in my code, I know right off the bat, oh my God, that's an object, right? So if I wanted, I could update my code, and guess what? I'm not going to. I'm a little lazy, so I'm not going to do it. All right, let's keep moving on here. Next, you'll notice a little area of the slides here. We're going to call this part stale data, right? This next section. So what if, right, we want to have our object be able to calculate its own area, right? And it says, notice the rectangle class doesn't have a field to store this. And the truth is, we don't need to store it. It's a calculated value, right? So we can write a get area method to return the computed area, but it's not necessarily going to a data field like a variable, right? And pulling the information out. It's just doing the math. All right. So let's grab this and add that to our program. Once again, it's going inside the rectangle class, and I'm going to put it at the bottom. So now we have a get area method. We don't need to send anything to it. These properties should already be set. So all I have to do is multiply them and return the result. And we're all good. Return type is a double. So if I want to get the area of the kitchen, I'm just simply going to console right line the kitchen dot get area. And then you notice what happens here too. Is like as you're adding methods to your objects, you're typing your code and Visual Studio reads your object, reads its method, and puts it up on the IntelliSense list for you to select it. Pretty slick, right? Yeah, that is pretty powerful, actually. All right, so the kitchen has a length and a width set. We haven't done that with the dining room or the bedroom, right? Let me see if I have any values here I can throw in there. I don't, right? But if you wanted, right? For example, I could also set values for dining room length. And let's make that, I don't know, 12.5, something not quite even. And then we'll say dining room dot width. And once again, let's do 11.0, something like that. I don't know if that's too small for a dining room, but then for the dining room, I can also do a right line and do dining room dot get area with parens, right? And then that'll output that as well. Bedroom, I'm not worried about that. I just want to show you that you can use it on any of the objects and it will work. That's kind of a weird underline. Oh, yeah. All right. So here we go. Let's run it. And then you'll notice the output. So 10 times 14 is certainly 140. And then for the dining room, 137.5, I'm taking it on faith that that's the correct multiplication, right? But it shows you that we put the values in and then we can extract them with those methods. This is not a stored value, it's a calculated value. But because we're pulling the information in, we still use the keyword get in front of it to imply we're pulling the information. Right, so that's that method. There's another way that you can do this, and this is kind of interesting, is I can also, where I declare the area property, I mean, if the calculation is really that simple, as this one is, I can, inside the definition of the data field itself, just say get and have a return length and width. And then notice the difference in pulling that information back. Right. Now, what's kind of interesting about this approach is, right, this is a method. And by doing the thing that they just demonstrated, I don't have to change any of that code, right? So I can just take this and then notice here, once again, capital letter, right? And so I'm going to add this. Oh gosh, let's put it below width, right? I'll put it right here. So we'll say public double area. We only have a get, we don't have a set, right? We're not going to allow people to set it because it's not something they can set. It's set by the calculation. So it only has a get. And then I refer to that with a capital A, and then I treat it like a regular property. So with each one of these, I can do console right line dining room dot area and get the same calculation, right? And I'll do the same with the kitchen. And so you really kind of basically what it's telling you is, when a calculation is really simple like this, you can do this, right? And you know what? Either one works, as you're going to see in just a moment. So if I run it, right, still get the same result on both. Which one's cleaner? I'm going to argue, I think this one's a little cleaner. But a lot of us old school programmers, real frankly, we're just so comfortable doing it this way. Because why? Because we've always done it that way. So we just keep doing it that way. But I think the more modern, like fresh, cool way to do it is probably like this, right? You know what? It's easier. But either one works, doesn't matter, right? I think syntax wise in your code, when I'm calling it in, this one looks a little cleaner too. It sure saves me from the possibility of not including one of the parentheses, right? So if you guys have ever done that by mistake, like forget a parenthesis, forget to close one or open one or whatever, right? This approach kind of eliminates that problem. All right, let's go ahead and close this little program run here and let's keep pressing forward. All right, so now we get to the concept here of avoiding stale data. And it says, could we have had a field for the area? Should we have? Okay, this is very subjective. I just kind of gave you my opinions on it. And it says, how would an area field have gotten its value? A setter of its own? So in other words, what it's saying is, should I have just set up areas like one of these, and then I can calculate it? And the answer to that is, yeah, you could, but how would you set that value? You'd have to calculate it still, one way or the other. So should we have? I'm going to say no, and how would it have gotten its value? A setter of its own, recalculated whenever length and width are updated? Yeah, that doesn't make sense, right? Because it wouldn't happen, basically. It says returning the freshly computed area prevents it from becoming stale. So the reason that we calculate the area on the fly and don't store the value is, okay, well, I did a remodel and I blew out a wall in the bedroom number 1, and now bedroom number 1 and 2 are one room called the master bedroom, right? And that area, if it was hard set, would no longer make sense. So it makes more sense to calculate it, because if the data can change, right, you can set and get it, then the calculated values can become stale, air quotes. All right. Things to note. It says getter and setter methods should only do one job. They should only set one value. One line one line of code in the body usually suffices. Don't write something like this. So their example is set length, where it returns a double. We send the length in, it puts it in X and stores it for some reason. And then we say length equals X, and then we return X. None of that really makes sense, right? If we're setting the length, all we really want to do is we want to take this and put it into our length thing and be done with it. We don't need to put it in a different variable and then take that variable and put it in the other variable. Nonsense, right? This is not necessary. Really what we're trying to do is we're not even trying to return a value. Ultimately, what we really want is a statement that says length equals len and be done with it. So don't do too many things in your getters and setters. Getters and setters should be very simple, right? So like if we're returning an area, that's a simple calculation. So we can go right to the return statement and the math, right? So it says getters return a value, but have no parameters. So we're not sending anything in to get this. We're using the values that are already in the object. Okay, setters have one parameter, but return void, right? Well, this is because we're setting the internal name, but we need to have something to send to it for that to happen, right? It doesn't return anything to the program body. What it does is it sets the name inside the object, right? Yeah, I guess we have a bonus slide here, by the way. So bonus, expression body definition. If a method or property only have one expression or statement as the body, you can use a shorthand syntax. So this is kind of neat. Check out the syntax. So as a method, right, I can use this approach. So I can say public void set name, string name, and then what is it doing? So no curly brackets. Notice the little, yeah, and what do we call this? We call that a lambda expression, by the way, the equal greater than, and it has nothing to do with math or comparison. And it's just doing the brute force work. So if it's a really simple statement, I can replace, for example, the set name method that I created with this syntax. And you know what? I'll just do that as an example here. So right below it, I'll just paste that in. And now, of course, it's conflicting because I already have it. So I would comment this one out, and then it's fine, right? Now, this is underlining red because really we need the underscore here for the way that we're doing it. But that's an approach. If you're only doing that one simple maneuver, I mean, you got to admit that's a little bit less to type, or at least less to look at. It takes up less screen real estate. Same thing. So this one where we're getting the area, this one I won't actually make active, right? But I'm just going to paste it in, and I'm just going to say, or you can do this, right? And I'm just going to paste that in, right? Until you have it as reference, and then we can comment it out. So your choice, right? Either one is fine. Once again, old school programmer, I'm more comfortable doing it the longhand way because that's how I've always done it. So I usually don't even think about doing it this way, but it is in my head. And maybe if I did more C#, like coding work professionally or whatever, I would take that approach from doing it day to day. So I think, hey, if you can do it the more modern way, the truncated way, that's what I would go for. So I think that's pretty cool, right? Because, think of all the lines of code you're saving. If I can just do it in one little statement like this, well, I can do statement after statement and put them right next to each other, super efficient, rather than scroll to find stuff, right? And it does the same job, it still works. So if I run the program, I'll still get the same results, just to show you, right? Still works. Okay. All right. I think once again, we've reached a break point. So I'm going to pause the record. Okay, we're back from break, and now we're going to move on to a fresh topic, which is constructors. And I've kind of already alluded to this a little bit because it's really kind of hard to talk about objects and classes and what this whole new thing means without talking about a constructor function. But, it's kind of like answering the question and kind of reinforcing the answer, basically. And so basically, a constructor is a special method or function that is called automatically when an object is created. So whenever we invoke the new keyword on an object or a class, that's why we see those parentheses there, because there is a method that automatically creates it. Now, what's kind of interesting, right, is let's take a look at our code really quick, right? We're doing that already. We're saying new rectangle, but when we go down here, there is no function inside of our rectangle class called rectangle. It's just the rectangle. Okay, so if there isn't one defined, it still builds the object with the information that's here. So it basically builds the object with all this code inside of it, right? Now, when we actually design a custom function, that becomes a whole different thing. So for example, it says it performs initialization like assigning default values to the field. Now, for us, the default values have been so far zeros for numbers and null for the other things, the string, the name of the object. So normally, if we are creating an object, though, check it out. It requires 4 lines of code the way that we've done it so far, right? So we have to say rectangle box, new rectangle. Then we have to set the name. We have to apply values to the length and width properties. And so if we want to construct it, we got to type all 4 lines of code to construct it, right? But what if we just want to create it and have all that stuff travel into it immediately right when we're doing the constructor function. Well, we can do that, but it requires a little bit of work to make that happen. So inside the class, we will actually declare a function or method with the same name as the class. So notice the class is called rectangle and the constructor function is called rectangle also. Same exact spelling. And it does accept the parameters in this order: the name of the object, the length, and the width. And then inside the constructor function, notice what we're doing is we're applying the name to this dot name. And for us, it'll be this dot underscore name. And then the length and the width properties will be sent in and then applied to the capital letter version. So here we use lowercase, right? And then uppercase here to match the property name. So let's go ahead and copy this in and add it to our program. So I'm just going to grab this code and I'm going to add it here, right? And now normally where do I place this in my code? Well, if I have a bunch of data fields, right, I'm going to put this at the top. And I think, it might make sense to actually label some of this stuff. So top part of a class is typically the data fields and properties, so we can kind of refer to them as kind of the same thing, but so data fields right at the top. Then once we get past the data fields, which end here, so I'm just going to put a little note: data fields and here, right? And then this is a good place right at the top. The very first method, this is how I was taught and how I usually do it, is where we will place the constructor function. And so I'm just going to put a little comment here above it. This following method or function, right, however you refer to it, is the constructor, right? It's expecting to receive the name, length, and width all in one fell swoop. Of course, my name is underlining red because I decided to go to the approach of using the private naming convention of underscore. And then if we want to create another room, the way that we accomplish it, so let's say we have, another rectangle that we're creating. Let's see if I can type it. And what do we want to call this one? Master bedroom or the den. Let's call it the den, right? So we'll call it the den. And this is going to be a new rectangle. But now that we have a constructor function, I have to send values in. So I have to give it a name. So I'll call it den. The size of it would be, it's going to be huge, of course. It would be 24.5 feet by 30 feet. Right, so we have plenty of room for the big screen TV, all the couches, the pool table, the dartboard, the bar, all the stuff that goes in the den. Fireplace, right? We need a fireplace too. All right. And that will work. Now, I want you to notice what's happening to the kitchen, the dining room, and the bedroom, though. Now, this constructor function is not finding its way, right? Because this one is taking over the construction of the objects. And this is saying, hey, wait a second, you're not applying any values here, and we're expecting values. So notice there's no argument that corresponds to the required parameter of name, length and width, so for etc. So in other words, now it's become required that we do it like this. All right, so I'm going to leave the example there. We'll come back to it in a little bit, but I just want to kind of show you how it operates. So if we use a constructor function, one thing that you should notice, right, is there's no return type, not even void. So this is how you know it's a constructor function, because in between public and rectangle, it doesn't say double or string or int or void or any of that stuff. It's just missing, right? That's one of the indicators, right, that it's a constructor. It says our first rectangle class didn't have a constructor, so why were we able to still do what we did, right? They call that, by the way, the default constructor. So when a class doesn't have a constructor, it already does it. It kind of does it automatically in the background. It just looks at your data fields. It builds the object, doesn't put any values in it. You have to do those manually. It doesn't take any arguments, which we figured out. And then normally what we call these are zero arg constructors or no arg constructors or default constructors. And I tend to call them default constructors personally, right? Um, Now, once you've written one that it does accept parameters, the default one goes away, the one that was automatically created. And so, as we discovered by looking inside of Visual Studio, this doesn't work anymore. So, if you want it to work, then what you have to do is you have to create a no arg, you have to manually create that and put it in. And so, notice this one accepts no parameters, right? And then you need to basically set values for those now and come up with like some defaults that make sense. Like, for example, like length and width need to be greater than 0, right? So we'll set them to 1 and then name will just become unknown. So let's take this code and add that code in also. And so I'm going to drop that into my class file now, right? And normally where, the way that I usually do it, right, is I put the most parameters at the top and then work my way down. Some people do it the other way. It doesn't really matter where you place it. And what I'm going to say here is this replaces the no arg constructor now that we have one above. So this becomes required, right? That we add it if you want to allow people to use this approach. Notice how the underlines went away, right? So now like the ones that don't throw any values in, now it will work. I do need to fix this one line here because we're using the underscore approach on name. Okay. So now if I create a generic room with no constructors, those are the values that will go in. So I think what would be really pertinent to do here, just to show how it works, right, is let's take a look at some of the code that we've added here. And I'm sorry I'm bouncing around so much, but I've created the kitchen and dining room, right, which have some values, like the names. Kitchen, dining room, bedroom have names. The kitchen has a length and a width. The dining room has a length and a width, but the bedroom one doesn't, right? And then the den has got all of it. So what we're going to do is for the bedroom, for example, let's do, we're not going to get area, but we are going to show the length of the bedroom and the width of the bedroom. And what should those be? 1, right? Because we didn't apply them, so that's going to take the default value of 1. And then for the den, we'll do console right line, and then here, let's change this to, den dot, let's get the name. Right. And then with the den, we can get the length and get the width. And you know what? We can also get area. Let's use the property approach and just do area. Right. Now, even though it's set to default values, that will calculate. Right. So let's run it and I'll show you what I mean. All right. So here goes the run. Right. So there's the kitchen, right? The dining room. All right. So now we get to the kid's bedroom. There's the 1 and 1. And then with the den, well, we remember with the den, we set the values up here, the name, the width, and whatever. And then I got a den with 735 square feet. That's pretty good. Some people don't have houses that big or apartments that big, right? But it just shows you that when we now have a default constructor or NORAD constructor that we built, it's automatically saying these values. And so then if I build
And you would have to use
an,
it area, just area.
the area here,
Yeah, it would be
yeah,
get area.
yeah. Well, you know what? I can switch it to get area. So if you want, I could do it this way. Both of them work.
Okay.
Yeah, and just to prove it, Anthony, just really quick, right? Notice same number.
Right, gotcha. Okay. Just
All right, so we
make
did it both as a property
and
and as a method.
kind of
Um, to add one more example here, right? Like if we add, for example, we do a rectangle, and I don't know, let's say we create a well, we already have a den, so I was going to make a man cave, but let's just call it closet 5 or something like that. And you know what? I don't think of my closets as having names. So I'm just going to do a default constructor on that. But then I'm going to do all of this stuff relative to that closet, right? And then I'm just going to copy that, paste, 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 right? And now when I run it, that did not get any name, even. We never set it. So now it should say unknown for the last example. So watch unknown 111, right? 1 times 1 is the area of 1. So that's correct, right? So all of those are kind of getting hard coded. So that's a nice little example, I think. All right. Moving along. All right. So it says uninitialized local reference variables. And it says declaring a reference variable doesn't create an object. Okay, so this is kind of weird. In other words, if I do this, I'm allowed, I can create a variable waiting to hold the object, but it hasn't been created yet. And I can do it in a separate step. So I can do this and then say box equals a new rectangle and throw in the stuff and it's created. I never, ever, ever use this approach, by the way, but it is doable. So you can create the variable first, put nothing in it, then instantiate the object and store it. But it does show you that the creation of the memory space and the instantiation of the object are really 2 separate steps. And we're kind of combining them. Just like when you create a variable, like an int called num, and you don't put anything in it. And then the next step, you say num equals 5, right? Same approach, but we're using objects instead of simple data things. All right. There's also kind of this other little thing that you can do too, right? And so we call this an object initializer. And it says you can create an object, set initial values with shortened syntax that calls the NORAD constructor, then sets the properties. And it says since methods, mutators, modify the data after initialize, they cannot be called within an object initializer. So like take a look at this kind of approach, right? So we'll say rectangle basement, new rectangle, and then we take the properties and we set them like this inside of curly brackets, and then we can set the name separately, right? All right, so the point of this is because these are properties and I can just kind of say that equals this like a regular variable, I can use this approach, right? But because the name can only be set with a mutator method, I can't do it with a name. That's got to be a separate line of code. Okay, once again, from a practical standpoint, I don't really use this a lot, but times when I do use it is when I have a whole bunch of properties that are like numbers that need to be pumped in, and I have the numbers available and I can make a list like that and it's nice and clean to look at. That's a situation where I might use it. But please be mindful of the fact that there's a comma there, right? So the ones in your code that are really, really simple data fields, you know, like length, for example, or even this one that has like some parameters set on it, or width, right? Those you can set that way. Area you could not, because it's only a getter, right? You can't set anything there, and it's calculated. But length and width in this program can be. Okay, moving on. Now we're moving into a little bit higher level concept here, which is the concept that we can take an object that's created off of a blueprint and then move that around our program like we move variables around. And when we do that, we are moving the whole thing, or at least we kind of think we are, right? So this is where it gets a little weird, right? So it says, when you pass an object as an argument, the object's memory address goes into the parameter, not the object, but the thing, its memory address. So it's pointing to the object. This is kind of weird, right? So, kind of a, you know, and we had this issue too, like when we were talking about copying arrays, right? Like if you make a copy of an array, they're both pointing to the same memory address. You guys remember that? This is very similar because they're both complicated objects is really what it is. So for example, if we have a candle class like this, so we have a class called candle, and then we have a Boolean islet. So this is a true false. And then we have 3 methods, right? So think about this. What they're really trying to say here is they're trying to take a candle as an object, and what's its essential property? It's got a flame or it doesn't. Is it lit or not? Yes or no, true or false, right? And then, well, what would you do with a candle? What are the things that a candle would do? Well, you could light the candle, so is lit turns to true, or I could blow it out, so is lit becomes false, or is it shining? You know, is there light coming from it, right? And that's a true false also, right? But this is to check to see if it's lit. So if the candle's lit, true comes back, so it is lit and shining, right? So if we take this example where we have a birthday cake, right? And we're building a program, we create a new candle, right? And that candle is called candle, right? And then we have some other method here called happy birthday that receives candle as an argument. And then when it receives it, it lights it. So it triggers the light method, right? This turns lit to true. And so when I say this, I'm lighting the candle, right? Because you have to light the candle saying happy birthday. Then we run the console write line to see, is it lit? What's the response? True, right? I hope your brains are latching on to that, but that's what's happening. Now, notice, happy birthday calls the light method on parameter C, but C is pointing to the same object as the variable candle, right? So in other words, we're taking this candle object, we're throwing it into a method, we're calling it C. And so inside that method here, the C is really the candle. They're both pointing to the same memory address. That's how this is lighting the object we're passing in, but it's also the same object that's out here. So this is the Y. So in other words, when I manipulate that object inside of a method, I am actually manipulating the object. It's not a copy of the object, even though in variable naming, we have the same name. So this kind of explains a little bit why we don't want to name things the same, because they are referencing the same object ultimately. Okay, so I know that's pretty heady kind of stuff, but you know, you would think that, right? So like the candle's on the table, I'm telling one method to light it. Is it lit or not? Well, here it says fault, but it is actually lit. You know, is kind of the point. All right, so now we have a little try it out to do here, and I'm trying to like see if we have enough time to accomplish this. I'm going to pause for just a second. All right, so we want to try it out together. And I just reassured that I had my examples here conveniently located so I can just pull them up quickly. I am going to come over here to Visual Studio and I'm going to close the current program that I'm working on. And what I'm going to do is I'm going to create a new project, same kind of procedures that we've been using all along here. This will be called, oh gosh, what will we call this? Let's call it mod 6 try it. That's what I called it last time, or module 6 try it out. And I think this is like ingredients. And I'm naming it verbosely, so next time I don't struggle to find it like I just did. And I am going to use top level statements here on purpose. All right, so there it is. Notice the namespace is what I called it. So that's kind of like the grand thing. We are going to have this program, and I'm going to put a little comment here. This is the driver program. So this is where we're going to run everything from when it comes down to it. Now, in terms of what we're going to do to build this, so first instruction is as follows. It says create a program with a class named ingredient. Now, so far, we've been putting the classes in the same file, but I thought maybe it's a good idea. Let's try putting a separate file in here and see how that works, right? So you get a little bit of a taste of that. So I'm going to go ahead and I'm going to create a new program, actually a new file. It's going to be a C# class, right? So you see this interface that we have here, right? And it is going to be saved, and notice it's being called class 1. I should have named it. All right, so I'm gonna change this. You know what? Let's start that over again. Let's try it again. Don't say it. And let's do a different approach here. I'm going to do it from this interface. I'm going to do a right click on the solution. And I want to show you guys where I'm right clicking, right on top of the mod 6 tryout ingredients thing. I'm going to choose add new item. And you know what? I can just choose class, right? So that just takes me right there. And now I want to name this ingredient, right? And so I'm just naming it ingredient, and then I'm going to click add. And so the reason I do that is it's part of the same structure, right? And notice how it added a whole bunch of like using statements there. Also notice that it doesn't know whether or not we need a main method on this, right? So we're not going to use one. And we're calling this internal class ingredient, but I'm going to switch internal to public, right? So that other parts of the program can access it, most notably the program file. And then we are asked, right, to add 3 properties: name, quantity, and measurement, right? And so what I'm going to do is I'm going to bring 3 private fields in, right? So I have name, quantity, and measurement, right? So those are my data fields. And then what else are we asked to do? All right, create a 3 argument constructor that accepts all 3 values. All 3 values. All right, so let's do that. And so I happen to have one all set to go. So here's my 3 argument constructor. So notice it's named the same as a class. Takes the name, the quantity, and the measurement. All right. Next task, in the driver class, ask the user for 3 values. Instantiate an ingredient object using the data and print out the ingredient. All right, so let's do that task. All right, so now back in the program file, we're going to prompt the user. So I'm trying to find see if I have my prompts coded here. I'm just trying to not have to redo all my prompting basically. All right, so here we go. It's a matter of finding the right example. Okay, so here's my prompts. So we're prompting ingredient, sugar, whatever. Very timely for Thanksgiving too, right? The quantity, 5 cups, right? That's what we put in our Kool-Aid, 5 cups of sugar. And then our measurement, right? I guess cups, right? Okay, so we're prompting, we're storing all the values, right? And notice these names don't have to match up at all with what's going into the object, not one bit. The next thing that we're going to do is we're going to instantiate the object. So we're going to build a new ingredient. We're going to call it our ingredient. And actually, we're just going to do this approach. And we're going to send in the ingredient, the quantity, and the measure, right? And then we're going to output those. So let's just do it very simply, like so. Now, I'm doing gets on these, right? Because we haven't gotten quite that far yet. But if I want to retrieve those values, given my current setup, so if I go to ingredient, I don't have like getters and setters set for these. I have to use the constructor, but I don't have any way to pull them back. So I do need to create the getters and setters in the ingredient program, or set the getters and setters. So here's an example. I'm just going to get the information, right? Because the constructor function will set them. And here's the 3 methods that will return them. So I have a get name, get quantity, and get measurement. All of those, right? Those are underlining green. How do I fix that? Right? If your brain says question mark, right, that's how you do it, if you're concerned about it. All right. So now I will save my ingredient class. I will save my program class. And now what's neat about this is the class isn't in here. It just happens to be in the same folder. And so all I'm doing is calling it in, basically. And notice it's not underlining anywhere where I say ingredient, because it is possible, or it is finding it basically in the folder. So here it is. Here, let's do a run. So let's, ingredient, I don't know, flour, quantity, 5, measurement, cups, So flour, 5 cups. Okay, so it's creating the object, putting the information in, and retrieving it. And this time we're using an external file for the class. Now, the advantage of this approach, if I want another program where I'm using this object or this class, I can just pick up the whole file and move it to that program, and I have the same capabilities. Pretty powerful, right? Especially, this is a really simplistic example. Can you imagine if it was really verbose with methods and data fields? Yeah, it would be very powerful indeed. All right, let's move on with our examples, right? So now we're going to learn the concept of overloading and overloading method. So this is kind of a weird topic, but when we have more than one method that's in an object or a class that have the same name, we can do that. That's a lot. That's weird, right? Because normally, like if I have like one function, I can't create another function with the same name. But if they have the same name and a different size parameter list, right, then we're allowed to do it. This is really, really strange, right? And or if that object is different. So for example, this one here accepts and returns an integer, right? So accepts integer value, right? Takes 2 integers in, sums them, and returns the sum. And notice this one here also takes 2 parameters, but it takes them as strings and it adds them together, but really it's concatenating them, and returning a string is a concatenation. So I don't think this is a really good example of overloading, but when we take an overloaded method, I think really what they're meaning is they have different size parameter lists typically. That's how I think of it. But it's also possible to have them set up so that one takes integers, one takes strings. They do different things, but they have the same name. Both are allowed. I think that's really weird, right? That's called overloading. So takes two parameters. This is integers. Takes two parameters. This is strings. Both work depending on what you send to it, right? All right. So when I do this and I'm sending in numbers, now I got one that accepts strings and one that accepts numbers. What am I sending in? I'm sending in numbers here, right? So this call to one of those functions will bind to it provided it accepts the correct data type. So it'll bind to the one that takes, the right stuff in. So C#, it says, uses the method name and parameter list to determine which to call, and that's called the method's signature. So returns an int, receives ints. Returns a string, receives strings. So if I'm sending in strings, this one will operate. If I'm sending in numbers, that one will operate, right? One thing that's kind of weird about this, it says things that aren't part of the signature. Okay, so the return type's not technically part of the signature. The access specifier, public, private, whatever, that's not part of it either, nor are the parameter names. So like, what these are called don't matter, right? The important part is the name and the data type of the stuff that it's receiving, right? We can also overload constructors. We kind of already did this. We have the default constructor, which happens automatically. But if, we set one that accept parameters, then we have to define a default, right? And so this one accepts no parameters, right? This one accepts 3. And it's not unusual that maybe that same program could accept 2 parameters or 4 parameters or whatever. It's all in how you code it. So you can have multiple methods with the same name that receive different parameter lists, right? Even if the parameter lists are different, they're not the same size. And that's what I typically think about when I think about an overloaded parameter list or an overloaded method. That's what I think of, is usually the different sizes of lists, not the different types of data going in, but both work, right? So why overload? It generally makes the classes a whole lot more versatile. So they say, consider a bank account class with the deposit and withdraw methods. One pair that takes strings, one that takes double, right? And then whatever happens internally to convert stuff, both would work. So in other words, if I did a withdrawal method and I typed in numbers, I'm withdrawing $50 from my account, great. Or if I do it verbally and just type out 50, and then I have a code that converts the word 50 to 50 to do the withdrawal, both would work. Who cares, right? You give the flexibility to the user, right? So that's why you overload. It gives you flexibility in how you use the program. All right. So this little try, it says modify the ingredient program to include an overloaded default constructor. So for example, I happen to have one handy, as you might imagine, right? So in the ingredient list, I have the constructor that takes 3 parameters, but then I also have a freshly coded default one that I have to put in since the other one overrode it. And so if they send in no parameters, this one would be fine, right? And so the default does this automatically, and then we're overloading it. So we can adapt to either scenario. That's really the situation there. Let's move on to our final topic for the evening. We have a whopping 7 minutes left. So let's see if we can kind of pull it off. We also have what we call custom collection types. All right. So when we are working with objects, right? So like we think, all right, we can put data fields in there, which are kind of like variables, and we can make them public or private, but we can also use complicated data structures inside of our objects. For example, I could create a, so notice, we can use our custom classes as the data type for a list object. So in other words, I can create a list of rectangle objects, not integers, not strings, not doubles, but of objects. Now, think about the power of this. Now I'm creating a collection of objects that I've created as opposed to a default data type. Very, very powerful. If I'm creating a list, you put your, your blueprint name, or, your class name here, and then you create the list, and then you call the constructor function, right? So now you guys are recognizing what that is. And then I can just go ahead and start creating rectangles, right? Like I normally do. And then I can add this rectangle that I created called shoebox to the list of rectangles called boxes, like this. I just treat it like a regular list, but now I have this list object, which holds multiple things. And now I'm putting objects inside of them, and each object has data fields and methods attached to it. All right. You guys feeling how deep this goes? This is really, really powerful. All right. You're like, why the heck would I ever want to use this? Okay. So that's one of the reasons, and I'll show you why you want to use it. All right. The other approach that you can do too, this is, okay, so we create the list, then we create an object, then we put the object in the list of objects, right? Another way to do it is you can actually instantiate the object inside the add command. So I can take the new part of the statement, put it inside the add parentheses, create the object, and then put it here. How is it getting named? Well, it's getting named right here. Right, that's its name. So it still can access it by name. Right, so that's what we call a custom collection type. Once you have a collection, right, it can be iterated over as usual. So for example, now I have a list of objects, and I can traverse all those objects with a list, or with a loop, right? So for example, for each rectangle, right, this custom object, in our boxes list of rectangle objects, we'll call each one a box. We can get the name, get the length, get the width. So if I have like 20 rectangle objects, I can run one for loop and get all the information on all the objects all at once. Deep, right? Pretty deep, pretty powerful. We're, multi layers of data structures here, which I think is pretty darn cool. We will use this stuff, by the way, as we kind of work on this ingredients and recipe thing. There's this whole concept that kind of goes with it. And it says you can populate a list with an initial set of objects using shortened syntax. So for example, here comes the var keyword, by the way. When I have boxes and I say new list rectangle, this is saying I'm creating a list of rectangles, by the way. Right? And then I can just feed in all the object declarations and the constructors right here and create a whole bunch of objects all at once. And then, oops, once again, and I'm sorry, I went back past it so quick. I can then iterate over or output all that with a loop. Very, very powerful, you guys. All right. So if you're reading data from the user, you can also, it says here, create your object first and use the setters as you read the data. So for example, I can create a rectangle, add that rectangle to the boxes list. Remember this, so this is a list, the boxes is. And then I can just prompt my user to enter in all the information, right? And it gets applied to whatever object I've created, right? And then I can take those objects, right, and I can take them and start adding them. So it says if you're reading the data from the user, you can use local variables to read the data, then make an object with them once you're finished, right? So I'm store them in local variables, and then I can take those local variables and put them in the declaration, right, and then add that to the list, right? So the hint is this is kind of a hint on how to do the homework, basically, where we can use the same code to prompt them for every object we create. So I can just go down a list. It's like, for example, if I have an ingredient is part of a recipe, right? And most recipes have multiple ingredients, right? So I had an example of like flour, 5 cups, right? And then I might have like sugar, 2 cups, butter, 1 stick, et cetera, et cetera. And I can list all my stuff. So this, like, you think of that complex object and you go, why on earth would I ever use that? Well, here's an example, right? A recipe has a list of ingredients, and each ingredient has a bunch of details to it. And those are complex objects. And ultimately, that list the grand list is maybe the recipe, right? Now, what we are running out of time to do is to do these try it outs. So here's what we're going to do next time when we get together, right? Which means you're going to watch it in the video. You can watch the videos and see these examples. So you would have to look at the videos from last year. But normally, if we met on Thursday, I would code through this. So if you guys watch the videos from last year, and I don't know if it's the end of the lecture video or the beginning of the exercise video, it's one of those 2 spots. I show how this is done. So I'm going to cap this video here. We're done for the night, folks. A lot of material to absorb. So I will see you at the next